And you can clearly find that some sort of stability is achieved using this circuit when you compare this with fixed biasing circuit. So we have just analyzed the circuit using applying KVL at the base side. Now we will apply KVL at the collector side. So collector side means I'll be choosing this path. Okay, again, two voltage source you have, VCC and VCE. See, VCE is not marked explicitly here, but you should not neglect the voltage source VCE at the collector side. So two voltage source opposing. So VCC minus VCE equal to IC into RC plus IE into RE. And through that resistance, whatever current is flowing, you consider that. You need not be the same current should flow through your resistance, just like we have resistance in series. No, here in transistor we have three different currents at three different terminals, right? So accordingly apply what current is flowing through what terminal. So uh, either see here the emitter current and collector current will be approximately same. If you assume that possibility, you can write VC equal to VCC minus IC into RE plus RC. You can get this expression. It is just an approximate expression. Or if you want to have the separate value of IC and IE, you can very well go with this expression. They have just simplified just to eliminate IE from the expression. So they have assumed the emitter current and collector current are going to be approximately same. And you can find the emitter voltage VE. You know, voltage of the emitter is given by IE into RE as by Ohm's law. Okay, so this is the collector current expression for the KVL at the output side of your biasing circuit. See, when you add a resistance RE, the equations will slightly change. You have to account for the inclusion of RE in your circuit. And the voltages you see, VCE means it is VC minus VE. VBE means VB minus VE. So you can find the individual voltages of the terminals VC, VB, VE, and you can find the corresponding voltages VCE and VBE. Generally, the notation is VAB means VA minus VB, the voltage at the first node minus voltage at the second node. Here, if you see VCE means, see here VC minus VE. VBE means VB minus VE. So once you know all the voltages, you can find the voltage at the terminals VB, you can find voltage VC, and you can find the voltage VE. If the circuit, if any question in the exam demands you to find the individual voltage, you can find the voltage from all these expressions.